Bismillahirrahmanirrahim. In this experiment, I am going to find out the heat capacity of this solid. This solid had a mass of 50 grams. Okay. Now I need a calorimeter. This is the calorimeter with a stirrer. Now I am going to find out the mass of this empty calorimeter. Now let us find out the mass of this empty calorimeter with stirrer. With the help of this electronic balance, I am placing it carefully on the electronic balance, and I found that the mass of this calorimeter is 37.9 grams. Okay. Now what I am going to do, I am going to fill this calorimeter with water. I am taking some water in this, I am pouring some water in it, and almost like half, little more than half we have to fill this calorimeter with water. You are not going to fill it completely with water. Now again we are going to find out the mass of this calorimeter with water. Again I have to place it on the electronic balance to find out the mass. So I got to know that the mass of the calorimeter with water is 109.4 grams. Now what next I am going to do? I am going to find out the temperature of this water in the calorimeter. For this I have this thermometer. I have to place this calorimeter in the wooden box, and I have to place this thermometer in it. I will have to take care that this thermometer must not touch the walls and the bottom of this calorimeter. Okay, you must take care of it. It must be suspended like this. It must not, the bulb of the thermometer must not touch the calorimeter, the walls of the calorimeter and the bottom of the calorimeter. And this wooden box is used to minimize the heat losses. Okay. Now after some time, when the temperature on the thermometer becomes stable, you will have to read the reading. So I got to know after some time when it will settle down and no fluctuation in the temperature is occurring. So I got the temperature is 32 degrees Celsius. Note down this temperature. This is the initial temperature of the water in the calorimeter. Okay, this is the initial temperature of the water in the calorimeter. Now next thing, what we are going to do. This is the mass of which we are going to find out the specific heat capacity. We are going to find out the specific heat capacity. I will have to tie it with thread. Okay, and then I will have to drop it in water. I will have to immerse this mass in water very carefully, so that it must not touch the walls of this beaker and not the bottom of the beaker. In the same way, you can see that this thermometer is also suspended like this, that the bulb of the thermometer must not be touching the walls and the bottom of the beaker. Now you will have to wait for some time, so that this mass must be getting the temperature equal to the temperature of boiling water. Whatever the temperature will be there, we will have to note after some time. You can take almost 10 minutes. Now you can see that the water is boiling. Now I am going to note down the temperature of the water. Now here you can see that this temperature on this thermometer is 101 degrees Celsius. So this is the temperature of the boiling water. I kept it boiling for almost 10 minutes. The mass of which we are going to find out the specific heat capacity, that is also in it. So you will have to make sure that it must be heated up fully. Now the temperature of this boiling water and the temperature of this mass is 101 degrees Celsius. Now what next we are going to do? Very carefully I am going to shift this mass into this calorimeter, so that minimum heat losses must be there. Heat must not be lost. Minimum. So very quickly you will have to move this in this calorimeter. Now you can put the lid on the calorimeter, so that minimum heat losses must be there. You have the stirrer to stir it. I have turned off the burner. Now you will have to give it some time. You can also stir it like this, so that heat must be transferred sufficiently from this mass into the water and the calorimeter. Here what is the rule? In the meanwhile it is getting the heat, and I am also stirring it like this. The heat lost by that mass of which we are going to find out the specific heat capacity, that will be equal to the heat gained by the calorimeter and water. Okay, after some time we noted down the final temperature of this mixture of calorimeter and this mass in this calorimeter. So we got to know that this temperature is 36 degrees Celsius. The initial temperature of the water in the calorimeter was 32 degrees Celsius. When we have shifted this mass into this, now its temperature has been raised to 36 degrees Celsius. Now we have taken all the readings like the masses and the temperatures, initial temperature and the final temperature of the mixture. Now with the help of these readings, we are going to do the calculations. देखिए जी, I told you that the heat lost by the solid which I showed you, that solid which I heated up at the temperature of 101 degrees Celsius. So that solid, when it was dipped in the calorimeter, then that solid will lose the heat energy. That heat energy will be gained by calorimeter and the water in the calorimeter. Heat gained by the water in the calorimeter and the calorimeter, because that heat, whatever the heat was lost by that solid, that heat will be gained by the water in the calorimeter and the calorimeter, stirrer, thermometer, etc. We are considering that there is no heat loss. So after inserting it in the calorimeter, we found out that the final temperature of the mixture of all these things is 36 degrees Celsius. Okay, this was the final temperature. Now we have to see that what the changes in temperature occurring over there when we have inserted the solid, because you know that initially the solid was at the temperature of 101 degrees Celsius. Finally, the temperature of the mixture got 36 degrees Celsius. It means the temperature of solid was decreased. From here you got to know that the temperature of solid was decreased. You know that the formula for specific heat capacity, that Q is equal to mc delta theta. Here delta theta is showing the change in the temperature. Final temperature of the calorimeter after, here you can write down calorimeter, water plus stirrer plus thermometer. So all these things are included in this calorimeter. Okay, the water in the calorimeter, because I told you that when you have inserted the solid in the calorimeter, so that will the mixture of water, calorimeter, thermometer, stirrer, all these things are gaining the heat energy. So here we are only considering water and calorimeter. So we are only considering that whatever the heat was lost by that solid, that heat gained by the water and the calorimeter. Okay, we are considering only these two things. According to these, we are going to do the calculations. Main thing is this, that how to apply the formula. From here, we have to find out the specific heat capacity. So as you know that, as I equalize that heat energy of this system has been converted to this. So here we have to apply the formula mc delta theta. If I am applying everywhere mc delta theta, so there will be confusion that which mc delta theta is used for which quantity. I am writing that m1 is the mass of the solid, m1 is the mass of the solid, and m2 is the mass of the calorimeter, and m3 is the mass of water. Okay. Now here I am writing that instead of m, I am writing m1, mass of the solid. Here water, the mass of water is 71. This is m3. And mass of the calorimeter is m2. This is m2. Now here the heat capacity of water is known. Here we have to apply the heat capacity of water. Here we are going to apply the heat capacity of calorimeter. The calorimeter is made up of copper. So what is the heat capacity of copper, if anybody knows? 390 joules per kg Kelvin. It is known quantity. Heat capacity of water is also known. I have told you what is the heat capacity of water. Is 4200 joules per kg Kelvin or degree Celsius, and the heat capacity of copper is 390 joules per kg Kelvin. These values are given in the books. You can find out the values in the book. We have to find out the heat capacity of the solid. Here I am using, like, say it is C1, it is C2 and it is C3. Now here in each case the delta theta, mean the change in temperature, is different in each case. As I told you that M1 is the mass of the solid, so apply the value. Okay, the mass of the solid is 0.05 kg and C1 is required to be found. So the C1 is the specific heat capacity of that solid which we used in the experiment. So instead I wrote C1. Change in temperature of that solid, because initially that solid, when I inserted that solid into the calorimeter, it was having the temperature of 101, and later on when we waited for it, the temperature of the mixture became 36. So 101 minus 36 gives you 65. Okay. So 101 minus 36 gives you 65. So change in temperature of this solid is 65. Now on this side, the water in the calorimeter was initially at 32 degrees Celsius. After inserting that solid which was at 101 degrees Celsius, the water and the mixture temperature became 36. So what is the change in temperature? 4 degree, because 36 minus 32 gives you 4 degree. So here the mass of the water in the calorimeter was 0.0715 into the 4200 multiply into 4 plus mass of the calorimeter, the mass of the 0.0379 into 390. Change in temperature. Now the change in temperature of this calorimeter, that is also 4, because finally this is the temperature 36 degrees Celsius. The initial temperature of water in the calorimeter was 32, but it raised to 36 degree. So here again the change in temperature is 4. Now after writing these calculations, making C1 as the subject of this formula, you can find out the result. Please solve this and calculate. Okay, the final answer is 387.8. What should be the unit? Joules per kg degree Celsius or Kelvin. So this is the heat capacity of that material. We are talking about the specific heat capacity now. This is the formula. The formula which we are using is the specific heat capacity formula. So obviously here we are going to find out the specific heat capacity. Finally we got the answer that the specific heat capacity of that solid is 387.8 joules per kg degree Celsius.